Hi, and welcome to MegaSplat Development Log 22. This is for the 1.10 version, which sounds like I've only done one update to MegaSplat. In fact, I've done quite a few, but let's just keep going. So we've got some hot new features, and we've got some minor features that I've added, some requests from people, and a whole bunch of bug fixes that I'm really happy about. I love bug fixes. So let's just jump in and talk about some of the new features first, because that's always the most exciting. So in the last patch, I added this wonderful water system for stream-like waters, and basically you can turn on refraction and get the surface refracting underneath and get these foam areas around your rocks and stuff. And I'm really happy with how this came out. But I was showing this to a friend, and he had a little idea, which was something I've noticed as well, which is like, hey, when you're in the deep parts, like the water stops refracting so much. And that's true. Water tends to calm out in the deep areas and have a wider ripple and have therefore less refraction because the surface tends to be flatter. So I thought, well, wait a minute, I already have most of the information to do this. I can probably figure this out. Spent a little time on it and I added a new feature. Now it's pretty cheap, so I wouldn't worry about turning this on. It's only a couple instructions, but it is wrapped into its own feature anyway. And so over here, when you have puddle set to refraction, there's now an option for puddle refraction depth dampen. So if we turn this feature on, it'll compile the shader. And what we can do is go down to our puddle section, and we see this refraction depth calm. Now if I set this to 0, we're going to get the same effect we had before, where the deeper areas are just as rippled as anywhere else. But as I increase this, you'll see that this deep area here now is not refracting as much as, say, the turbulent water over here. And so that just adds a little bit more sort of a complexity to our surface, which makes the water look a little bit nicer. So I can show this really quick without the foam, which makes it a little more apparent. So if we turn off the foam, love the foam, so I hate to see it go. But if you look, you'll see that this high rock here, where the surface of the water is going right over it, is getting a lot of refraction, while this deep area is not. And if I turn that value back down here, you'll see that it becomes more even across the whole surface. So that's a nice little feature. You can balance that against your refraction strength and sort of get some more natural representation of water. So one other thing I did was I added support for conditional branching, basically flow control on the water. And so the refraction, actually, when you get out to a certain distance, it's quite a distance, it'll stop computing it. And it's pretty apparent when you don't have the foam on at this distance. But when you turn on the foam, you won't notice it at all. And so this actually takes a lot of expense out of the technique. I also halved the number of samples that are needed for the refraction effect because when I sort of prototyped it, there was some cleanup I could do to make that faster. And the other thing I did was invoke conditional branching, conditional flow control, whatever you want to call it, so that we only bother to compute the water surface where there is a chance that there is water. So that means that when I'm looking over here, I'm getting a much cheaper shader than when I look at the water, whereas before it would have computed the water for everything all the time. So on most modern graphics cards, that's going to be a nice speed up. Since a lot of these features are sort of for high end, it seemed like the right thing to do to bias it towards what high-end video cards will do well. So that's a nice set of optimizations. So let's talk about a brand new feature that I've just started on and hopefully will be really useful to people. So I'm going to change the puddle type to lava. Give it a second to recompile. And now what we have is that our puddles are now lava. And I thought a bit. I've implemented lava shaders before, and the way I generally do them is I have one set of UVs that I can just move a texture along that makes it really easy, and then I might flow map another texture inside there but I generally don't use just flow mapping for lava. And the reason is that in lava, you want these sort of chunks of darkened, hardened rock to be in the lava pool as well. And when you're flow mapping things, basically what you're doing is you're getting this repeating cycle. You move a texture a certain amount, and then you reset it back to where it was, and you crossfade between two of these, and that crossfading covers up the gap. Well, you can't really have rocks move down with the thing in the traditional manner that people do these shaders without a consistent set of UVs if you have to flow map them. So I had to sort of play around with this and come up with a technique, and I think it works pretty well. So the first thing you'll notice is that there's a lava texture, and I'll talk about the packing format for that in a minute. But I do have two examples here that produce pretty different types of lava, and they sort of want different parameters, but they should hopefully give you some ideas about what type of information you can put into the texture. A lot of this stuff ends up being about noise patterns, right? About getting a textural pattern that has a certain noise function to it of like, oh, it's big stones or it's little details. So you have a UV scale, which just allows you to scale the UV of this texture. And we have a blend width, which is similar to the blend width on the water. And then you have a maximum amount of lava. So if you wanted to bring in lava, like you might with puddles, you can do that. And then here's the flow mapping parameters. And what I'm going to do is show you that crossfade. So if I set the intensity to 1, and I set the speed to something really really low, what you'll see is this is just crossfading between these two offset textures. They're the same texture, but they're just in offset positions. So generally with any type of flow mapping, you want to get this low enough that you don't see that crossfading happening, but fast enough that you see the textures changing, that they're rolling and sort of changing shape as they move, right? That you get a good motion. So let's set this at 0.1 and this 1.05, and there we go. We can see that the textures are sort of oozing around and we're getting the right effect. So we'll skip down here to the colors. So you have a main color for your fog. For your fog, for your lava. And so you can see I can change that and get really weird colors. You have the edge color, which is essentially the edging around the rocks where the intersection happens. And that actually comes up onto the rock and creates a little bit of glow there. So we can come in, take that back. And then finally you have the highlight color, which is essentially the highlights on the lava. So those are the three colors that you use to define your lava surface. And then if we go to the parameters, you have a parameter called drying. And basically what this is how much of the rock dries. So if you want a fresh lava where things are very hot still and they haven't started drying into actual chunks of rock or attempted to and then melt again, which is really kind of what happens, you turn drying to 0. As you turn this up, you're going to see you're going to get more and more of these sort of dark chunks in this. And that chunk signature really does get defined by this texture choice. So if I switch to my other texture, you can see I get some very different looking sort of drying sections from this. Let me switch back for a minute, and we'll put that up a little bit. And then what we have is these 3 distortion parameters. And so what I had to do to get this to look a little better was distort the surface so that we'd get sort of a constant change to this. If I change the size, you can see that it's scaling the texture that it uses to basically distort that surface, right? And then we have the rate of distortion. So if we crank this way up, you'll see more of it. And if you crank it down, you'll see less. And then you have the amount of distortion here, the scale. And so, actually, sorry, I think I got that backwards. This is the texture scale of the distortion. So now we see very small distortion amounts. It's small details versus much larger details. And that's the amplitude. Okay. I need to come up with a better name that explains these two parameters better. So you can see here as I change the size, we're getting more distortion effectively. And the distortion is getting more turbulent. But as I change the scale, we're actually scaling the amount that we distort the original UVs from. That one's probably easier to see on the other texture. So I'll try to think up some better names for these parameters. But either way, you're going to basically play with them and try to figure out something that you like to get the kind of look you want. So let's just bring these down a little bit. And so yeah, that's basically the lava system. But let's go ahead and talk about these textures. So we'll start with the one we've been looking at. It basically has a normal map in the red and green channel. And in this case, I use this sort of puffy stones normal map to give it that puffy, rolly look that this lava has, like these sort of bits of puffiness. And then over here in the blue channel is this sort of gradient mapping texture. So basically where it's black, it's going to be the base lava color, and where it's white, it's going to be the highlight color. So it's going to end up, in this case, it's going to be red in the black areas and yellow in the highlights here where it's white. So that's the main use of the texture. It also acts as the input to that distortion field for doing the distortion. In fact, actually, I think I use all 4 of these for distorting, because again, these are sort of general noise textures when you look at them as individual channels. So when you're pushing UVs around, you can just kind of get a good result by like getting a bunch of noise data and using it to push things around. So the final one is used for the darkening. That's its primary use anyway. And essentially, where we have white is where the darkening is going to be applied. So if you look at these little bits here that are darkening, right, you can see that those are the little white bits coming out here. If this texture was a little bit more not so crinkly and a little bit more shapely, with like big solid shapes here, then you'd get big solid shapes of stone forming from the drying. So, you know, getting the right textures for these things is really paramount. I'm probably going to spend some time trying to get these textures better for the next patch. So if you really like a particular one, I would, you know, go ahead and cache it off, because I may change it. Who knows? I may change the whole system, but what I have now I think looks pretty decent, and yeah, and that's pretty cool. So what else did I add? I added a clear button to the texture cluster field on the cluster array. Somebody had asked for that because they like to clear out their clusters and hit auto again. And that's basically it for features. We can talk about some of these optimizations. Now I talked about using dynamic flow control for the puddle stuff already. The same thing is true of the lava. It's going to branch on this and only bother to compute lava where this stuff is potentially lava. Additionally, lava takes 3 texture samples, I believe it is right now. No, sorry, 4. So that's, you know, that's pretty cheap. That's less than a refraction. I have the number of samples needed for refraction. And I also fade out parallax mapping so that we don't bother to compute it way off in the distance where you can't really see it anyway. So basically I spent a lot of time optimizing the per pixel shader cost on all of the sort of existing features. Now let's get into the bug fixes. There are actually quite a lot that I was trying to get into this patch. So I've ran into this problem for ages where sometimes things just magically stop working in Unity shaders. Things that work otherwise suddenly stop. And if you actually look at some of the MegaSplat code, you'll find little hacks in it occasionally to prevent these things from happening. So I'm going to go down into one of these fragment sections here. And so this is one, we had a problem where when you ran parallax mapping, sometimes it wouldn't work in certain modes. But if you turned on, say, a texture sampler for something, suddenly it would start working again. Well, I have not been able to get a small repro for Unity on this. I spent a bunch of time trying to round down this bug so that I could give them something that was simple to look at and reproable. They have this full shader, but basically what I have to do is take the view direction, which is what we use to compute the parallax, just add a large number to it, saturate it, which means it's going to end up 1, and multiply it by the albedo. So basically the albedo is going to multiply itself by 1, which is going to make it the same. But now the compiler sees that we're using this view dir and doesn't do whatever it does to it. I'm not exactly sure what it does to it. It may be taking it in world space instead of tangent space. It may be just giving me 0 for it. I'm not sure. But by using it explicitly, here, as opposed to in the parallax function where it gets used, then that fixes it. You'll notice I have the same thing on these debug outputs. So it didn't bother me so much on the debug outputs because, again, these are not used for runtime code. And this fix is very cheap, but I still don't like having, these extra instructions. Like basically there's a couple extra instructions here just to make a feature work because something strange is going on. So like I said, I spent a bunch of time trying to get a simple repro for Unity. Completely failed at that, but I did manage to work around the parallax bug. There were still some issues with terrains with the texture graph. Basically, if your size of your terrain was different, your splat control texture was a different size in your alpha map, there were some issues there that were fixed. Let's see. I fixed the world versus local space projection. It was a bug in my math. I originally thought it was a shader compiler doing what it was doing to the other stuff, but this turns out to be a bug in my math. And so I fixed that so that when you move a world space projected object, it will now slide around on the texture like it should. I fixed the warnings that are in 5.5 and 5.6. These are harmless, but they're really annoying. And people are always like, hey, you got a warning in here. And they get really kind of leery of warnings. And I get it. It is a major pain to test these things because you got to test it in all the different versions and make sure you didn't break it in one. So now that 5.6 is actually working for MegaSplat, it's like, okay, I'm going to go fix these. And then there was an issue where if you used a custom function, custom functions were introduced in the last version. Basically, if you use that with a tessellated shader, then essentially it would not compile correctly because, in one case, the terrain, Unity terrains don't have tangents, and it would try to pass the tangent and then die. So I missed that in my testing, which I'm sorry about, but that is now fixed. Now, the one caveat is that in some cases you don't have a tangent. I compute the tangent myself, so I send you that in most of those cases. And if you're on the shadow pass or something like that, then the tangent is going to be 0, but that's fine because you shouldn't be doing anything with the tangent on the shadow pass. So that's it for this version. I'm hoping to finish running my tests on it tonight and get that uploaded, and then update the documentation and all that stuff. I hope you dig it, and come talk to me on the forums if you have ideas or anything like that. Okay, thanks a lot.